Hello Griffin users. So in this video I'm going to be talking about some more in-depth usage of tuning screens. In the last tuning screen video I basically showed you how to set up this type of display right here, where we essentially have one value that we can manipulate. For me in this scenario I have an optimizer running, and this value that I'm able to change is the target, set point target for the optimizer. So I update that to 10 and we should see this targeting 10 now, and we do. So let's take a look at this optimizer that I have going here. So right now I have basically all the values except that target, which is right there, hard-coded. So we have the mins, the maxes, the fixed or not fixed, and the initial values and distance penalties, all hard-coded. Now, what if we wanted to make these values accessible to the user outside of the application, so we don't have to go in here and manually change things, do a save, refresh? That's pretty cumbersome. Well, we can do that using tuning screens, and we can also display the final output from the optimizer in that same tuning screen as well. So let's take a look at how we might do that. Now with this first tuning screen I did it using this table view component, which you can access right here. But for this tuning screen where I'm going to be showing all these values for the optimizer, it's going to be a lot more convenient to use a matrix, and this is the other way of creating a tuning screen in Griffin. So I'm going to create a matrix component, and let's go ahead and open this up. So I'm going to want to have a row for each input of my model, and because I'm going to be making the minimum, the maximum, the initial values, and the optimized values accessible through this tuning screen. So let's go ahead and create 15 rows. We can copy our row names over from the optimizer, and let's create a couple columns. So we're going to have a minimum, a maximum, and we'll call it the optimized value. So right now this is just a matrix. It's available within Griffin in the application for logic use, but right now this is not accessible externally as a tuning screen. To make that happen, we have to click this Use for Display button, and we can give it a title. Or maybe we'll call it Optimizer. Now I'm going to go through and configure the columns. So when we're creating our tuning screen, there's a few options here. First, we need to give it our title in our array, which is how we're going to refer to it internally within Griffin. And then we give it a title for the display. The display title can have spaces, it can have new lines, whatever you want to do. I'm just going to call this min. This has to be all one word, standard Griffin variable format. Now let's go through for a minute and talk about the different options here. So first we have use column and display. If I uncheck this, that means in that tuning screen that appears externally, this column will be hidden. But I definitely want this showing, so we leave that checked. User can update values. So that is pretty self-explanatory. In the tuning screen, the user is going to be able to change the values in this column. So I want that checked because I want our minimum and maximums to be modifiable by the user. The column, the display header I already explained is what it's going to be, what the column is going to be titled in the external display, the tuning screen. And the column type here, we have three options: numeric, date, time, or string mapped. So numeric is the standard. Basically, if we just want to display a generic number, we're going to use this option. A date time column you may occasionally need if you're tracking dates in a tuning table. And how you would use this, basically, you would need to pull in one of these date time components, and then you would need to assign the value to the seconds since 1970 from that date time component. So for example, we would take our matrix here and we would assign the value, pull up the date time component, seconds since 1970. Now if you select date time for the column type and you assign a value of the seconds since 1970, that will correctly display a date in that column. And you can choose the date format here. If you click the help button, there's some explanation of the date format here. This is the standard one that gives you months with the preceding 0, days with the preceding 0, 2-digit year, and hours and minutes with the preceding 0. You could put seconds if you needed more precision. You could delete the date if you wanted to. But that's how you get a date time display in the column. String mapped is an interesting option. basically what this does is gives you one, you need to enter one row for every integer starting at 0. So we would have, instead of 0, 1, 2, we're going to have something like good, bad, and ugly. So now if the value that's input into this matrix is 0, it's going to display good. If the value is 1, it's going to display bad. If the value is 2, it's going to display ugly, and so on. And you can use HTML formatting here as well. So for example, those closing tags probably aren't even necessary, but we'll put them in there. Copy this, paste it and paste it. Let's make orange here. Let's make red here. So now this would give me different formatted backgrounds for the different values. So for 0, it's going to have a blue background. For 1, it's going to have an orange background. It'll say bad. And for 2, it'll have a red background to say ugly. But for our optimization, we're using values between 0 and 1. They're not whole integers, so this isn't useful in this particular case. But that's how you would use that feature. For example, if we wanted to see this in action, why don't we add another column here? We'll add another column for fixed or not fixed, and then we can display that feature as well. Okay, so we're using numeric. Now, the next option is horizontal alignment, self-explanatory as well, left, center, or right. So in the display, that column is going to be either left aligned, center aligned, or right aligned. Header click link. This is an interesting one, a feature I've never actually used personally, but what this will basically do, you can select one of your different views here, and if you click the header of that table in the tuning screen, the header of that column in the tuning screen, it'll open up this other display. Value-based background color. So these options work only with the numeric column type. It disappears for the other types. And what this basically does is you can say, you can add rows here, and depending on the value, it's going to select a color that's an interpolation of the different colors that you enter here. So this 0 could be purple, and green could be 1. And if its value is 0.5, it's going to be halfway between purple and green. So you can indicate your values as being good, bad, or neutral using this color scheme here. It's pretty handy. Another little trick I'll teach you is that if you want to set up multiple columns with these colors, it can be very tedious to set this table up every time. And it doesn't work to copy this table the normal way, which is click the first cell, hold shift, and click the last cell and press copy. But what you can do is click in the first cell, hold down shift, and then click with the arrows down to the bottom right corner, and then press Control C for copy. And now if I go ahead and open a different column, I can paste these in, and that'll make that a lot easier. Okay, so let's set these columns up now that we've explained the different column types. So this is going to be our min column. User can update values. We're just going to call it min in the display. Let's go ahead and center align these. Now for columns where the user can input values, I'm not going to use the value-based background color because we highlight the columns where users can change the values differently, and that'll override that highlighting and potentially make it not obvious that you can change those values. So I'm going to not use that feature, but I'll use it for the optimized values column. So here's our max, center align. Now this column is going to be our optimized values. Call this optimized, and in the display, I'll go ahead and give it 2 words there. Center aligned, user cannot update, and I will do value-based background color here. Now this is going to vary between 0 and 1 because that's how my model is set up. And I'm going to give a green color for 0, and I'll give a red color for 1 to indicate full activation of that input. Now this column is going to be my fixed or not fixed, and this is also going to be something that the user can modify. And in this case, I do want to have string mapped. And I'm going to go, I'll do something like this because I like to use the HTML background features. So we'll go body, BG color equals green. And we'll call this fixed. And this, so that means that this input will not move. Copy this and make the next one. We'll call this optimizing, so that value is able to move. Make it a red background color, and we'll do white text on this line. We should probably do white on both. Okay, and user can update values. Now, I don't really like the location of my fixed column here after the optimized value, so I'm going to rearrange my columns, move that up there, so we have min, max, fixed, and optimized. Okay, so I'm thinking this is set up pretty good, but what we haven't done yet is point our optimizer at the values that we created in this tuning screen. So we've got the optimizer here, we've got the matrix here, and we need to go through and make our min value look at the min value from our matrix. So let's go ahead and pull this up. We're going to want matrix min call 1. Sorry, a little display bug there. So that's going to be our format. Now I don't want to look for these one by one and do that for all the different rows. So what I'm going to do is I'm going to copy our columns in here and go into my text editor. If you've seen my Griffin tips and tricks video, you'll understand what I'm doing here. Control A, Control Shift L, home button, matrix 1 dot min dot, and now I've got all 15 columns. Paste them in here, telling me these are not valid values because I forgot the I in matrix. Okay, little typo there. Can be fixed easily enough. And there we go. Okay, now let's do find replace min with max. That'll give us our max values. And for our initial values, we can actually input the last optimized values. And we need to do fixed as well. And that's looking good. Save, refresh. So the last step I need, you can see I still have 0 for my optimized values. What I'm missing here is assignment of the optimizer output into the matrix to complete the loop. So let's go ahead and do that real quick. My repeater is going to run through the number of rows in my matrix. And for each row, I'm going to assign to the matrix optimized value. For that index, I'm going to assign the optimizer optimized inputs value at that index. Okay? There's my comment. Try save, refresh. Okay, so now our tuning screen is pretty much complete. We have our mins available, our maxes available, our fixed and not fixed. I can change any of these. Now this is pretty much static because it's re-inputting these optimized values as the initial values, and the initial values are always considered as one of the possible solutions. So it's basically sitting on these values because they're already a perfect solution. It has no motivation to change. If I were to copy a bunch of zeros into the initial value, we would see these moving around again. And there they go. let's make, oh, I did want these fixed. That's why they're green. Let's try that again. Okay, so if I want to fix one of these values, I will type a 1 here. I actually have this backwards. I want 0 to be optimizing, and I want 1 to be fixed, because that's how it works in the optimizer. So let me go ahead and fix this column here. I need to swap the order of my rows here. Let's close and reopen this. Okay, so now they're all optimizing, and that makes a lot more sense because they're all being changed by the optimizer. So let's put one of these to be fixed. So now we see this guy's pinned at 0. What happens if we make the minimum of 0.5? Stays at 0 because that was the initial value. That's interesting. Let's move one of the ones that is optimizing. Let's put the minimum at 0.9. We should see this one between 0.9 and 1 every time now. And it is. Okay. Let's make it the maximum 0.91. So we can see those values having their effect. And we see an interesting property of the optimizer, which is that the minimum and maximum will only take effect if that input is not fixed. Good to keep in mind. So there you have it. That's a basic demonstration of more advanced tuning screen use. Thanks for sticking with me, and I'll see you in the next video.